Hello YouTube family, let's provide a solution given this algebra problem, which is a cubed plus 5a, this is equal to 42. So this is the value of a. Now from what we have here, the solution from what we have that a cubed plus 5a, this is equal to 42, okay? So we're going to take 42 on the left hand side so that we'll have a cubed plus 5a subtract 42, this is equal to 0, okay? Now from what we have here, we have a cubed plus 5a subtract 42. 42 can be expressed as 27 plus 15, which is equal to 0. Now from what we have here again, this is a cubed plus 5a subtract, now 27 can be expressed as 3 raised to power 3, okay? Subtract 15, this is equal to 0. Let's combine a cubed and 3 cubed. We will have a cubed subtract 3 cubed, okay? They have the same exponent, plus 5a subtract 15 can be expressed as 5 times 3. Now if you say 5 times 3 is the same thing as 15, this is equal to 0. Now from what we have here, this particular part, this is actually the difference of 2 cubes expressed as a cubed minus b cubed, which you can express as a minus b, a squared plus ab plus b squared, okay? Now applying the difference of 2 cubes property, we have that a cubed minus 3 cubed, this is the same thing as a subtract 3, we'll have a squared plus 3a plus 3 squared, which is 9, okay? Now let's substitute this back to the equation. I'm going to have a subtract 3, we'll have a squared plus 3a plus 9, okay? Now we have plus 5a, okay, minus 5 times 3, this is equal to 0. Now from what we have here, we have that a minus 3, a squared plus 3a plus 9, okay? Now you can see that 5 is common here, so we factor out 5. So you'll have plus 5, a subtract 3, this is equal to 0, all right? So a minus 3 is common, so we factor out a minus 3, so that we'll have in parentheses a squared plus, this is 3a plus 9, okay, plus 5, okay, close the bracket, this is equal to 0. So that means that the first value of a, that is, we have two parts here, we have a minus 3, and in the parentheses, we have a squared plus 3a plus 9 plus 5, okay? So we have a subtract 3, this is equal to 0, and that means that a1, can call this one a1, this is equal to 3, which happens to be a real root. So this is a real root, all right? Now from what we have here, now the second part of the parentheses is a squared plus, now we have 3a, 9 plus 5, this is the same thing as 14, this is equal to 0. And this is a quadratic equation with a equal to 1, b equal to 3, and c equal to 14. Now let's assess the discriminant value of this quadratic equation so that we can check the nature of the roots of this quadratic equation. Now the discriminant value is equal to b squared subtract 4ac. Alright, okay, so let's substitute the value of b. B is 3, so 3 squared, this is 9, subtract 4 times 1 times c, which is 14, okay? So this is the same thing as 9, subtract 4 times 14, this is 56, so 9 subtract 56, this is equal to negative 47, which is less than 0. And this means that we have two complex roots. We have two complex roots, okay? Or rather imaginary roots, which are in the form of a2, which is a plus ib, and a3, which is actually a subtract ib, okay? So let's apply the quadratic formula to solve for the values of a. The quadratic formula from what we have here, which is a is equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a. Okay, so let's quickly substitute these values of a, b, and c, so that negative b, this is negative 3, plus or minus the square root of b squared minus 4ac, and from our calculation we find that that is b squared minus 4ac. This is the same thing as negative 47, of which you have calculated earlier, divided by 2 times 1. Okay, so the same thing as 3 plus or minus the square root of, now negative 47 can be expressed as 47, subtract negative 1, divide everything by 2. Okay, and this is equal to, this is 3 plus or minus the square root of negative 1, this is I, square root of 47, divide everything by 2. Okay, so here we have two complex roots, okay, which is actually a2. We have a2, which is equal to 3 over 2 plus I square root of 47 divided by 2, and we have a3, which is 3 over 2 subtract I square root of 47 divided by 2. Now, these are two complex roots. These are two complex roots. Okay, so our algebra problem has got 3 solutions. We have 1 linear solution and 2 complex roots. Thank you for watching. Follow the steps and kindly subscribe. Thank you.